I/O package. I/O, or the abbreviation for input-output, is a feature in Golang that is used as a standard for the input-output process. In Golang, all input and output mechanisms must follow the standard I/O package. Reader. To read input, Golang uses an interface contract called reader which is contained in the I/O package. Writer. To write to output, Golang uses an interface contract called writer found in the I/O package. I/O implementation. The use of I/O itself in Golang is found in many packages. Previously, for example, we used CSV Reader and CSV Writer. Because the I/O package is actually just a contract for I/O, we have to do the implementation ourselves. But fortunately, Golang also provides a package to implement I/O easily, namely using the Bufio package. Let's start by creating a string reader. Creates a string reader named reader using the string's newReader function from the strings package. The string hello world is passed as input to the string reader. Reading from the string reader. Now prepares a buffer to store the data read from the string reader. In this case, a byte slice of length 12 is created. Uses the read method of the string reader to read data into the buffer. The read method returns the number of bytes read, n, and an error, if any. Checks if there was an error while reading. If an error occurs, it prints an error message indicating the failure to read. If reading is successful, it prints the number of bytes read, n, and the data read from the buffer using fmpprintf. Now creating a file. Uses the osCreate function to create a new file named example.txt. If the file already exists, it will be truncated. If the file does not exist, it will be created. Checks if there was an error while creating the file, error equals nil. If an error occurs, it prints an error message indicating the failure to create the file. File creation is successful. It defers the closing of the file using defer file close. This ensures that the file is closed properly when the function exits, regardless of whether an error occurred. Writing to the file. Here, we prepare the data to be written to the file. We convert the string "this is an example file" into a byte slice, byte named data. Data is typically written to files in byte form, so we convert the string to bytes. Uses the write method of the file to write the data to the file. The write method returns the number of bytes written, n, and an error, checks if there was an error while writing to the file, error equals nil. If an error occurs, it prints an error message indicating the failure to write to the file. Writing is successful, it prints the number of bytes written, n, to the file using fmpprintf. Reading from the file. We initialize a byte slice named buffer with a length of 20 bytes. This buffer will be used to store the data read from the file. The seek method is called on the file object to set the file pointer to the beginning of the file, offset 0, using the I/O seek start constant. This ensures that the subsequent read operation starts reading from the beginning of the file. The read method of the file object is called to read data from the file into the buffer. It returns the number of bytes read, n, and an error. If reading is successful, we print the number of bytes read, n, along with the data read from the buffer using fmpprintf. We use buffer, n, to slice the buffer up to the number of bytes actually read, n. This ensures that we only print the portion of the buffer that contains valid data. Okay, let's run it. And this is the result.